Everyone remembers the Shelby Mustangs tearing up racetracks across America in the late 1960s. The image is burned into our collective memory. Carroll Shelby's blue and white racers dominating everything in their path. Ford's marketing machine celebrating victory after victory, and Chevrolet seemingly left to watch from the sidelines. But what if I told you that General Motors built a machine so powerful, so advanced, and so utterly devastating that they had to keep it secret from their own executives? What if the most radical racing engine of the muscle car era wasn't wearing a blue oval at all, but was instead hiding behind a bow tie built in numbers so small that most Americans never knew it existed? In 1969, while Ford bragged about their accomplishments and Chrysler flexed their Hemi muscle, Chevrolet's Skunk Works engineers created a street-legal race car that could obliterate anything on four wheels. They called it the ZL1, and only 69 of them ever left the factory. This is the story of how Chevrolet broke their own rules, defied corporate policy, and built the ultimate weapon in America's horsepower wars. And here's the kicker. They did it so quietly that even today, most car enthusiasts have never heard of it. To understand the ZL1, you have to go back to 1967, when General Motors was drowning in success but starving for racing glory. The first-generation Camaro had just hit dealer lots, Chevrolet's answer to Ford's wildly successful Mustang that had created the pony car segment 3 years earlier. But while the Camaro looked great and sold well, GM faced a serious problem. In 1957, the Automobile Manufacturers Association had enacted a racing ban, a gentleman's agreement that prohibited manufacturers from officially sponsoring racing teams or advertising their performance capabilities. General Motors, being the largest and most visible automaker, took this ban more seriously than anyone else. Meanwhile, Ford pretended the ban didn't exist. They funneled money to racing teams through backdoor channels, supported independent shops developing high-performance parts, and plastered total performance across every advertisement they could afford. By the mid-60s, Ford was winning everything: NASCAR, drag racing, Trans Am road racing, and even Le Mans. For GM's engineers, watching from behind corporate policy was torture. They had the talent, they had the technology, but they didn't have permission. So they did what passionate gearheads have always done when faced with bureaucratic obstacles. They found a way around the rules. The man leading this quiet rebellion was a soft-spoken engineer named Vince Piggins. Working from Chevrolet's product promotion engineering group, Piggins understood that if GM wouldn't officially race, they could still build the parts and sell them to teams who would. This led to the Central Office Production Order System, known by its acronym COPO, a loophole that allowed dealers to order special equipment combinations that bypassed normal production channels. Through COPO, you could get things the corporate catalog said didn't exist. The foundation for everything that followed was laid with the Mark IV big block engine, Chevrolet's redesigned V8 that debuted in 1965. Unlike the original W Series big blocks, the Mark IV featured improved breathing, better oiling, and a stronger bottom end designed to handle serious power. The standard production version displaced 427 cubic inches, but savvy racers knew the block could handle much more. In the engine's architecture lay enormous potential: thick cylinder walls, a deep skirt design that extended well below the crankshaft centerline for rigidity, and 4-bolt main bearing caps on the center 3 journals that could withstand tremendous loads. This wasn't just an engine, it was a foundation for greatness. Chevrolet offered various states of tune in production cars, from the relatively mild 385 horsepower version to the legendary L72 that produced 425 horsepower with its solid lifter camshaft and rectangular port cylinder heads. But even the mighty L72 wasn't enough for serious racing. When you went to the track against Ford's tunnel port 427 or Chrysler's Elephant Hemi, you needed every advantage you could get. Weight was the enemy, and the cast-iron Mark IV big block tipped the scales at over 650 pounds fully dressed. In road racing especially, where the Camaro competed in the Sports Car Club of America's Trans Am series, that weight hanging over the front wheels destroyed handling balance and punished brakes. Piggins and his team knew they needed something radically different. They needed aluminum. The all-aluminum ZL1 engine represented the pinnacle of American racing engine development in the muscle car era. Unlike simply bolting aluminum heads onto a cast-iron block, the ZL1 featured an aluminum cylinder block, aluminum cylinder heads, and aluminum intake manifold, shedding over 200 pounds compared to the cast iron L72. But building a reliable aluminum block that could survive the brutal stresses of a 7,000 RPM race engine required extraordinary engineering. Chevrolet turned to their partnerships with Reynolds Aluminum and specialized foundries that had been perfecting aluminum casting techniques for years. The block itself was a masterpiece of metallurgy, cast from A356 aluminum alloy, the same material used in aircraft components. It featured cast iron cylinder sleeves that were installed during the casting process, not pressed in afterward. This meant the sleeves were permanently locked into place by the aluminum that solidified around them, creating a bond that wouldn't fail under racing conditions. The deck surface was Siamesed, meaning the cylinders were cast so close together that coolant couldn't flow between them at the top, dramatically increasing strength in the most critical area. 4-bolt main caps secured the center 3 main bearings for maximum rigidity where crankshaft loads were highest. The crankshaft was forged steel, not cast, internally balanced and shot-peened to resist fatigue cracks. Connecting rods were forged steel, designed with larger 7/16-inch diameter bolts instead of the standard 3/8-inch hardware. The pistons were forged aluminum, designed with valve reliefs deep enough to accommodate the wild camshaft profiles needed for racing. The cylinder heads carried the 074 casting number that would become legendary among Chevrolet enthusiasts. These open-chamber aluminum castings featured massive rectangular intake ports and generously sized exhaust ports to move enormous volumes of air. The valves themselves were enormous, 2.19-inch diameter intakes and 1.88-inch exhausts, controlled by hardened steel seats pressed into the soft aluminum. The valve train ran through a solid lifter camshaft, not hydraulic, meaning manual adjustment and regular maintenance, but also the ability to rev far beyond what any production engine could tolerate. Valve springs were dual-coil designs capable of controlling the valves at 7,000 RPM and beyond. The intake manifold was an aluminum open plenum design that fed air through a single Holley 850 cubic feet per minute 4-barrel carburetor. In stock form, Chevrolet rated the ZL1 at 430 horsepower at 5,400 RPM and 450 foot-pounds of torque at 4,400 RPM. These numbers were fiction. Chevrolet deliberately underrated the engine to avoid insurance and regulatory scrutiny, but everyone who saw one run knew the truth. Independent dyno tests revealed the ZL1 produced closer to 570 horsepower at the flywheel and street trim, and race-prepared versions easily exceeded 650 horsepower. With headers, racing carburation, and proper tuning, the ZL1 could produce over 700 horsepower while still maintaining reliability for endurance racing. This was more power than Chrysler's legendary Hemi, more than Ford's tunnel port, and it came in a package that weighed hundreds of pounds less. But here's where the story gets interesting. GM's corporate policy prohibited installing engines larger than 400 cubic inches in any intermediate or compact car, a rule established to prevent the company from appearing too focused on performance. The policy was meant to keep GM out of trouble with safety advocates and insurance companies who were already targeting high-performance cars as dangerous menaces. This meant the ZL1, at 427 cubic inches, couldn't officially exist in the Camaro. Piggins had to use the COPO system to circumvent his own company's rules. In early 1969, Vince Piggins opened the back door with COPO 9560, a special order package that included the aluminum block 427 ZL1 engine, Muncie 4-speed manual transmission, 12-bolt rear axle with deep gears, heavy-duty cooling system, and power disc brakes. The engine alone added over $4,000 to the price. When combined with the base car, a ZL1 Camaro stickered around $7,300, an astronomical sum in 1969 when you could buy a fully loaded Impala for less than $4,000. This was supercar money for what looked like an ordinary Camaro. For comparison, the Iron Block L72 427 was available through COPO 9561 at a fraction of the cost, but that package couldn't touch the ZL1's performance potential. The staggering price reflected the engine's exotic construction and hand-assembled nature. This wasn't a machine built for profit, it was built for one reason: homologation. To race in NHRA competition and to establish the aluminum big block architecture as production legal, manufacturers had to produce a minimum number of street-legal examples. Chevrolet needed to build enough ZL1 Camaros to qualify the engine for competition, but they didn't want to build any more than absolutely necessary. The production numbers tell the story of just how exclusive this machine was. In calendar year 1969, Chevrolet built exactly 69 ZL1 Camaros. 69 cars, not 690, not 6,900, but 69 individual automobiles, making it one of the rarest production American performance cars ever built. The majority went directly to racing teams and serious drag racers who understood what they were buying. A few found their way to wealthy enthusiasts who wanted the ultimate street weapon, but these were not casual purchases. When you bought a ZL1, you weren't buying comfortable transportation. The engine had no provisions for air conditioning, no power steering, and barely functional exhaust manifolds that dumped heat into the cabin. The solid lifter camshaft produced valve clatter at idle. The clutch pedal required serious leg strength, and starting required finesse. Prime the carb, crack the throttle, and don't flood it. Once running, the ZL1 idled with a lumpy cadence around 800 RPM. But when you matted the throttle, all discomfort was instantly forgotten. The ZL1 didn't accelerate so much as teleport. The engine delivered its power in a savage linear rush that pushed you back into the seat and kept pushing until you ran out of courage, gear, or road. The sound was unforgettable, a deep bellowing roar at low RPM that transformed into a mechanical scream as the tachometer swept towards 7,000. Shift points came at 6,500 RPM, and you had to shift fast because the engine made power everywhere. On the drag strip, the ZL1 was absolutely devastating. Magazine tests recorded quarter-mile times in the 13.0 to 12.8 second range bone stock, running on bias ply street tires with full exhaust and factory jetting. But that was just the beginning. With headers, carburetor rejetting, slicks, and proper gearing, the same cars dipped into the low 12-second range, and serious tuners pushed them into the 11s without major internal modifications. Professional drivers like Dick Harrell and Fred Gibb campaigned COPO Camaros in NHRA Superstock and Stock Eliminator classes, where the ZL1's combination of massive torque and lightweight gave them a power-to-weight ratio unmatched by anything else in production. Where a Hemi Charger weighed over 4,000 pounds and a Boss Mustang pushed 3,600, a stripped ZL1 Camaro could get down to 3,300 pounds with minimal effort. The ZL1's aluminum engine didn't just reduce weight, it moved weight rearward, improving traction and balance. With proper suspension tuning and drag slicks, these cars could launch hard enough to lift the front wheels inches off the pavement, something previously seen only in purpose-built race cars. In NHRAA stock and superstock competition, ZL1 Camaros dominated their classes throughout 1969 and into the early 70s. Drivers would remove every unnecessary pound: heater, radio, sound deadening, passenger seat, spare tire, jack, even the hood insulation. They'd swap the heavy steel bumpers for fiberglass replicas, install lightweight bucket seats, and replace the glass windows with Lexan. The result was a street-legal race car that terrorized drag strips across America, establishing records that stood for years. Now here's where the ZL1 story gets even more interesting, and where legend and fact need careful separation. The Trans Am series in 1969 represented the pinnacle of American sedan racing, with rules that capped displacement at 305 cubic inches and required production-based engines. Ford's Boss 302 and Chevrolet's DZ 302 small blocks battled for supremacy on road courses from Sebring to Riverside. Roger Penske's Sunoco Camaro team, with Mark Donohue behind the wheel, had already broken Ford's early stranglehold by winning the 1968 championship using the iron block DZ 302 engine. They repeated that success in 1969, again with a small block, not with the stroked ZL1 aluminum blocks as some legends suggest. The ZL1 big block was too large for Trans Am rules and never raced in that series. But dismissing the ZL1's road racing impact would be a mistake. The aluminum big block technology pioneered in the ZL1 program pushed Chevrolet's materials, science, and engineering knowledge forward in ways that influenced everything that followed. The lessons learned, casting reliable aluminum blocks, controlling thermal expansion, and managing the interface between aluminum and iron informed Chevrolet's Can-Am racing programs and later production aluminum V8s. The ZL1 was part of a larger performance ecosystem at GM, where drag racing, road racing, and engineering development all fed into each other. While the DZ302 won Trans Am titles, the ZL1 proved that aluminum architecture could survive the punishment of professional racing, opening doors for future development. The existence of those 69 streetcars homologated the aluminum big block for NHRA competition, where it absolutely dominated and established Chevrolet's credibility in advanced engine technology at a time when Ford and Chrysler were still wedded to cast iron. The ZL1's reputation spread quickly through America's racing underground. Drag racers who'd spent years chasing Hemi Mopars suddenly found themselves facing Camaros that looked stock but ran impossibly quick. Street racers discovered that the innocent-looking coupe with dog-dish hubcaps and no badges could destroy big-block Corvettes and Cobra jets without breaking a sweat. The ZL1 became the ultimate sleeper, a car that didn't advertise its capabilities but simply demolished everything it encountered. Stories spread of ZL1s showing up at small-town drag strips and running times that seemed impossible, of street races ending before they started when the Camaro vanished into the distance. The engine's reliability added to its legend. While Hemis required constant maintenance and Boss Motors needed frequent rebuilds, the ZL1 just kept running. The forged internals and conservative factory tune meant you could race it hard all day, drive it home, and come back next weekend without touching anything. This durability came from Chevrolet's racing experience. The engineers knew that winning required finishing, and finishing required reliability. Every component was overbuilt for its task. The oil pump could supply adequate pressure at 8,000 RPM. The cooling system could handle sustained high-speed running. The ignition system delivered consistent spark under racing conditions. This wasn't a compromised street engine trying to be a race motor. It was a race engine that happened to be street legal. The ZL1 also represented Chevrolet's answer to a problem that had plagued American racing for years: how to make big horsepower without the weight penalty that came with it. Ford's solution was better aerodynamics and more displacement. Chrysler's answer was the Hemi superior breathing. Chevrolet chose advanced materials and precision engineering. The A356 aluminum alloy used in the ZL1 block was the same specification used in aircraft engine components, chosen for its combination of strength, thermal properties, and castability. Getting the casting process right required months of development. Early prototype blocks cracked during testing as engineers learned how aluminum expanded and contracted differently than iron under thermal cycling. They discovered that the cylinder sleeves had to be cast in place, not pressed in, to prevent movement under load. They learned that the main bearing caps needed to be torqued in a specific sequence to prevent distortion. Every detail mattered, and every detail was tested until it worked perfectly. This level of engineering was unprecedented in a production American V8. European exotic manufacturers used aluminum blocks in limited numbers, but no American manufacturer had attempted to produce an aluminum big block designed for the punishment of drag racing and the thermal stress of sustained high RPM operation. The ZL1 proved it could be done, and proved that American engineers could match or exceed anything coming from overseas. The development process behind the ZL1 reveals just how committed Chevrolet's engineers were to perfection. Testing began in 1967 with prototype aluminum blocks subjected to torture that would destroy conventional engines. Engineers ran them at sustained peak RPM for hours, monitoring temperature, oil pressure, and bearing wear. They deliberately over-revved them to find the breaking point. They thermal cycled them from cold starts to full operating temperature hundreds of times, searching for any weakness in the casting or sleeve interface. When problems appeared, they redesigned and tested again. The cylinder head development alone took nearly a year. The 074 castings went through multiple iterations before engineers achieved the flow characteristics they needed while maintaining structural integrity. Port shapes were refined using flow bench testing, a relatively new technology in the late 60s. Valve angles were calculated to optimize mixture motion in the combustion chamber. Spring pressures were tested at various RPM ranges to prevent valve float without creating excessive friction. The camshaft profile was ground and reground dozens of times, seeking the perfect balance between low-end torque and high RPM power. This wasn't guesswork. It was methodical engineering backed by thousands of hours of dyno testing and real-world validation. By the time the ZL1 reached production, it represented the culmination of everything Chevrolet had learned building racing engines since the 1950s. Understanding the ZL1's place in automotive history requires appreciating what it meant to build an aluminum V8 in 1969. Today, aluminum blocks are commonplace, found in everything from economy cars to supercars. Computer-aided design allows engineers to optimize every aspect of the casting before a single part is made. Modern metallurgy provides alloys specifically formulated for automotive use. 55 years ago, none of this existed. Engineers worked with slide rules, hand-drawn blueprints, and educated guesses informed by experience. Aluminum casting technology was primitive by modern standards, borrowed from aircraft and industrial applications and adapted for automotive use. The fact that Chevrolet created an aluminum big block that could not only survive but dominate professional drag racing speaks to the brilliance of the engineering team. They were quite literally inventing the future, solving problems that wouldn't become industry-wide concerns for another 3 decades. Every modern aluminum V8, whether it wears a Chevrolet bow tie, a Ford oval, or a European crest, owes a debt to the ZL1 program. The lessons learned, the techniques developed, and the proof of concept established in those 69 cars created the foundation for everything that followed. The business case for the ZL1 never made sense, which is precisely what makes it special. General Motors lost money on every single ZL1 Camaro they built. The development costs alone ran into millions of dollars, money that could never be recovered selling 69 cars. The hand assembly process meant each engine required dozens of man-hours to build, inspect, and test before installation. Quality control was obsessive because Chevrolet couldn't afford to have these engines fail in the hands of racers who would publicize any problems. From a pure business perspective, the entire program was irrational. But corporations aren't always driven by spreadsheets and profit margins. At least they weren't in 1969. Sometimes passionate people inside large organizations manage to push projects forward on sheer force of will, building things that matter for reasons beyond quarterly earnings. The ZL1 existed because Vince Piggins and his team believed it should exist. They believed Chevrolet needed a halo product that demonstrated engineering excellence. They believed the racing success and technological prestige would benefit the brand, even if the cars themselves lost money. They were right. The ZL1's dominance in NHRA competition and its reputation as the ultimate street terror created value that couldn't be measured in direct sales. It proved Chevrolet could build the fastest, most advanced engines in America when they chose to, and that proof mattered. The dealers who ordered ZL1 Camaros were taking a massive financial risk. A car that cost $7,300 in 1969 was an extremely hard sell, especially when it looked identical to a base Camaro that stickered for less than $3,000. Most dealerships that ordered them did so for their own racing programs or for specific customers who'd already committed to buy. A few optimistic dealers ordered them for inventory and quickly discovered that casual shoppers weren't interested. Stories persist of ZL1 Camaros sitting on dealer lots for months, occasionally years, while salesmen tried to explain why someone should pay twice the price of a normal car for something that looked the same but had a special engine. Some dealers eventually gave up and sold them at discounts just to move the inventory. A few ZL1s sold for less than their engine costs, meaning the buyer got the entire car and the engine for what the engine alone should have cost. These bargain sales created opportunities for drag racers to acquire the ultimate weapon at affordable prices, which ironically helped spread the ZL1's reputation. The more these cars won at the track, the more valuable the remaining cars became. By the mid-70s, even though muscle cars were out of fashion, knowledgeable enthusiasts understood that ZL1 Camaros were something special. Collectors began searching for them, documenting serial numbers, tracking down survivors, and preserving what remained of Chevrolet's most extreme production car. But nothing in Detroit lasts forever, and the ZL1's moment in the sun was brutally brief. By 1970, the world that created the ZL1 was already dying. Insurance companies had declared war on high-performance cars, implementing surcharges that made powerful vehicles unaffordable for young buyers. Federal emissions regulations were tightening, requiring catalytic converters and unleaded fuel that these engines weren't designed to burn. The horsepower wars that defined the 60s suddenly seemed reckless and irresponsible as America entered an era of environmentalism and safety consciousness. General Motors, ever conscious of its public image, backed away from performance even faster than other manufacturers. The corporation that had tried to stay out of racing in the first place certainly wasn't going to defend the muscle car era when politicians and activists came calling. The 1970 model year saw compression ratios drop, camshafts get milder, and advertised horsepower numbers plummet as manufacturers switched from gross to net ratings. The ZL1 was simply too expensive, too extreme, and too obviously focused on racing to survive. Chevrolet built no ZL1 Camaros for 1970, and the engine option disappeared from any paperwork. The COPO system that birthed it was gradually phased out as dealers found fewer customers willing to pay premium prices for outrageous performance. By 1972, even the mighty L72 427 had been neutered with lower compression and restrictive exhaust systems. The Arab oil embargo of 1973 delivered the final blow to what remained of the muscle car era. Suddenly, Americans waited in lines for gasoline, and concerns shifted from quarter-mile times to miles per gallon. The idea of a car built purely to go fast, with no regard for fuel economy or emissions, seemed almost obscene. The ZL1 faded into obscurity for nearly 2 decades. Those 69 cars scattered across America, many ending up in junkyards or stripped for parts by people who didn't understand what they had. General Motors had kept the ZL1 so quiet that many Chevrolet dealers didn't even know it existed. No glossy brochures promoted its capabilities. No magazine advertisements touted its victories, and the few magazine tests published at the time barely scratched the surface of what the car could do. As the 1980s arrived and interest in classic muscle cars began to revive, collectors started searching for survivors and discovered that ZL1 Camaros had become incredibly rare. Racing had destroyed many. Harsh winters claimed others. Finding an original, numbers-matching ZL1 became nearly impossible, and when one surfaced, it commanded prices far beyond typical muscle cars. Today, the 1969 Camaro ZL1 stands as the holy grail of Chevrolet muscle cars, valued at over $1 million for pristine examples. Only about 40 of the original 69 cars have been documented and verified, meaning roughly 30 are still missing, possibly sitting forgotten in barns or garages, their owners unaware of what they possess. The ZL1's legacy extends far beyond those 69 cars. The aluminum block technology pioneered in that engine influenced everything that followed. Modern LS and LT series engines from General Motors use aluminum blocks descended directly from lessons learned with the ZL1. The idea that you could build a lightweight, durable, powerful aluminum V8 for production use seemed radical in 1969, but became industry standard by the 2000s. Racing teams still seek out original ZL1 components for restoration projects and vintage competition. The engine's reputation for reliability and power remains unmatched even 50 years later. At vintage racing events across America, you'll find Camaros running ZL1 engines or faithful reproductions, still competitive against modern race motors costing 10 times as much. The sound of an aluminum big block Chevrolet winding to 7,000 RPM remains one of the most glorious mechanical symphonies ever created, a sound that takes older enthusiasts back to a time when American engineering dominated motorsports and manufacturers built machines that prioritized performance over profit. The ZL1 represents something we've lost in modern automotive culture: the willingness to build something purely because it's right, regardless of business case or corporate approval. Vince Piggins and his team of rebel engineers didn't create the ZL1 to make money or increase market share. They built it because racing matters, because engineering excellence deserves recognition, because sometimes you have to break the rules to prove you're the best. In an era of focus groups and quarterly earnings reports, that kind of passion seems almost quaint. But for those who remember, for those who heard a ZL1 at full song or felt one launch from a stoplight, that passion created something transcendent. The ZL1 wasn't just fast, it was purposeful, honest, and uncompromising in ways modern performance cars can never be. It didn't pretend to be practical or civilized. It didn't apologize for existing. It simply did what it was built to do better than anything else on Earth, and that was enough. When automotive historians discuss the greatest American performance cars ever built, the ZL1 Camaro deserves mention alongside the Shelby Cobra, the Hemi Cuda, and the Boss 429 Mustang. In many ways, it surpassed all of them, combining power, reliability, and racing success in a package that cost Chevrolet money to build and achieved objectives the corporation officially denied pursuing. The 69 cars that left Chevrolet's factory in 1969 carrying ZL1 engines weren't really production cars in any meaningful sense. They were race cars with license plates, homologation specials built to satisfy rulebook requirements, mechanical manifestations of pure competitive spirit. The fact that a few ended up on streets instead of tracks doesn't diminish their purpose. It amplifies their legend. Somewhere in America right now, there's probably a ZL1 sitting in a garage, covered in dust, waiting for someone to recognize what it is. There are stories yet untold about these cars, races yet undocumented, victories yet unrecognized. The ZL1 was Chevrolet's secret weapon. And like all secrets, parts of the story remain hidden even now. What we know for certain is that when General Motors needed to prove they could compete with Ford and Chrysler in the horsepower wars, they didn't build a slightly better Camaro. They built the most advanced racing engine anyone had ever bolted into a production car, wrapped it in an unassuming body, and let the results speak for themselves. Those results shook the drag racing world, established records that stood for years, and created a legend that grows stronger with each passing decade. Have you ever seen a ZL1 Camaro in person, heard one run, or maybe even been lucky enough to drive one? Do you remember when Camaros dominated NHRA Superstock? Or the sound of an aluminum big block at full throttle echoing across a drag strip on a Saturday night? These machines represent a moment in American automotive history when engineers were allowed to chase perfection, when racing success mattered more than profit margins, and when Detroit built cars that inspired passion instead of just transportation. The ZL1 story reminds us that the best things often happen quietly, without fanfare or corporate approval, when dedicated people refuse to accept defeat and push the boundaries of what's possible. If you enjoyed this deep dive into one of history's most significant and rarest muscle cars, subscribe for more forgotten American legends that shaped our automotive world. There are countless stories still waiting to be told about the engineers, racers, and dreamers who built the machines we remember, and every one of them deserves to be heard.